Okay, so every time you send an email, stream a movie, or just scroll through your feed, there's this incredible hidden system working in the background. It's basically a giant global post office for all our data. It is the invisible backbone of our connected world. And you know what? It all comes down to one thing: the IP address. So in this explainer, we're going to demystify what that is, and more importantly, why it's so critical to, well, everything we do online. No, seriously, just think about it for a second. You click send on an email, or you hit play on a video, and somehow that data just zips across the entire globe and lands on the exact right screen. How? How does that even work? Well, the answer is this simple but honestly brilliant invention that's pretty much the postal service for the whole internet. So, at its core, an IP address is just a unique number for your device. That's it. Think of it exactly like a mailing address for your house. Your computer, your phone, your smart TV, each one gets an IP address so that all those little data packets, like that cat video, know exactly where to deliver the goods. It's literally how devices on the internet find each other and start talking. Okay, so this digital address doesn't just, sit there looking pretty. It's actually a busy little thing. It has two super important jobs that basically make the modern internet possible. So let's break down what it's really doing behind the scenes. All right, job number 1, it identifies your specific network connection. Job number 2, it pinpoints your device's general location. Now, these addresses aren't just pulled out of a hat. They're mathematically assigned by this global organization called the Internet Assigned Numbers Authority, or IANA for short. And in the system most of us have been using for years, IPv4, this gives us a range of numbers that goes from all zeros up to all 255s. This created a huge pool of addresses, but, and this is a big but, it turned out to be finite. All right, this is where things get a little more interesting because not all IP addresses are created equal. To really get the difference, let's use a super simple analogy. I want you to think of your entire home network, your Wi-Fi, everything connected to it, as one big apartment building. So your public IP, that's the main street address for the whole building. It's the one single address the outside world sees. Your internet service provider, or ISP, gives that address to your router. But inside the building, your router acts like the super efficient building manager. It goes around and assigns a unique private IP, think of it as an apartment number, to your laptop, your phone, your smart fridge, you name it. It's a really clever system that lets all those different devices share one single public connection to the internet. And look, this distinction really matters for how you use the internet every single day. If you're a serious gamer who needs a direct connection, or maybe you're running a server from home, you're dealing with your public IP. But the reason your whole family can be streaming, gaming, and working online all at the same time, that's all thanks to your router cleverly juggling all those private IPs. It's just a brilliantly efficient system. Okay, so we've got public versus private down, but there's another key distinction we need to talk about: whether an IP address is permanent or just temporary. To get your head around this one, think about the difference between having a permanent reserved P.O. box at the post office versus just being assigned a random temporary locker every time you go to the gym. A static IP is just that, static. It's fixed, manually set up, and it does not change, ever. Businesses love these because their websites and email servers need a reliable, consistent address that people can always find. Most of us at home, though, we have a dynamic IP. This means every time you connect to the internet, a system called the Dynamic Host Configuration Protocol, or DHCP, which is probably running on your router, just plucks an available address from a pool and kind of lends it to your device for that session. It's super flexible and way more efficient for most people. Okay, time for a quick internet history lesson. The original system for IP addresses was, like we said, totally brilliant, but it had one major flaw. See, the creators back in the day never, ever imagined that we'd need an address for every single phone, every watch, every car, and heck, every refrigerator on the planet. The internet was just growing way too fast, and it was heading straight for a massive shortage. Take a look at this number. That's just under 4.3 billion. And that is the total maximum number of addresses possible under the original system, which we call IPv4. Now, back in the 1980s, that seemed like an absolutely astronomical number. I mean, who could ever use that many? But fast forward to the 2010s, and it was crystal clear. We were in big trouble. And that was the problem, right there. The world was literally running out of internet addresses. With billions of people getting online, and each of us having multiple devices, a phone, a laptop, a tablet, that 4.3 billion address pool was just drying up, fast. To keep the internet from hitting a wall and stop growing, it needed a fundamental upgrade. And the solution? It's called IPv6. And just look at the jump here. We went from a 32-bit address system in IPv4 to a 128-bit system in IPv6. Now, the difference isn't just double or triple. We're talking an exponential explosion. We went from about 4.3 billion addresses to a number so large, it's genuinely hard to comprehend. We're talking trillions upon trillions upon trillions of unique addresses. Now, it's really important to remember this wasn't some overnight switch. IPv4 served us incredibly well for decades after it was first deployed way back in 1982. But as we started hitting its limits in the 2010s, this massive, gradual, global transition to IPv6 began. And it's a process that's still happening today, all to basically future-proof the entire internet. And IPv6 is about so much more than just having a ton of addresses. It was designed from the ground up with the modern internet in mind. So it brings things like enhanced security features, much better and more efficient data routing. And this is the big one, it provides the foundation for the Internet of Things. It gives us enough addresses to connect literally anything we can possibly imagine to the network. Okay, so let's do a quick recap of the key takeaways here. First, an IP address is basically your device's unique postal address online. Simple. Second, you've got public IPs for your whole network and private IPs for all the different devices inside it. Third, most of us use dynamic IPs that are temporary, while some businesses need static IPs that are permanent. And finally, IPv6 is that essential, massive upgrade that's giving the internet a near infinite supply of addresses to grow into. And all of this brings us to one final, really exciting thought. We now have a virtually limitless supply of digital real estate. The question isn't if we can connect something to the internet anymore. The question is, what are we going to connect next? We're talking smart cities, intelligent farms, devices we haven't even dreamed of yet. The possibilities are, for the first time, truly endless. So, what do you think is next?